Assalamu alaikum. In this lecture, we will talk about the different hormones that regulate calcium concentration in the body, which is the parathyroid hormone, the vitamin D, and also extracellular fluid calcium concentration should be precisely regulated for around 2.4 millimole per liter, and this is very important because calcium play a very important role in many of the physiological process as outlined in this diagram. One of them is the contraction of muscles, either a skeletal muscle, cardiac muscle, or smooth muscle. The calcium is very important. Also, it is important in blood clotting because calcium, as you recall from your coagulation physiology, it is an important cofactor in coagulation process. Also, it is very important in nerve transmission of neural impulses. So, cases of hypocalcemia where the blood calcium reduced, it causes like increase in the excitement and firing of these neurons, which might cause a condition called tetany, which is a spasm of the muscles. Cases of hypercalcemia, where the blood calcium level is increased, this will cause the opposite. It will cause depression of the nervous system and also depression of the muscle activity. Also, the calcium, we don't forget, it's a very important element of the. How much calcium found in the body? Around 1 kilogram of calcium found in our body. 99% of this calcium found in the bone, in our skeletal bone. Only around 0.9% found inside the cells, intracellular, and only 0.1% in the extracellular fluid. So, as we said, 99% is in our skeleton, and that's why bone calcium provides a huge reserve if in case the body needs it at any time. So, a short-term maintenance of calcium level in the blood will require exchange with the bony calcium. Now let's see the extracellular fluid calcium we said. So the calcium in the plasma is present in three forms according to this graph. If you see here, around 41% is bound to protein, so it is not free. It is bound to blood proteins. Around 9% bound or complex with anions, so around 9% combined again with anions, so it is not completely free. And 50% of the calcium found in ionized form, free in the plasma. And this, the ionic calcium here, the free form here, is the one which is important for that physiological process we talked about, and this is the one which should be precisely regulated by the body, which we call it calcium homeostasis. So the level of ionized calcium remain constant by different mechanisms that are internally, what we call internal balance, and this causes an immediate adjustment for the calcium level. And we have external balance, which require things outside the body, and this will take time, what we call them slow adjustment. The internal immediate adjustment, this will control the plasma, the free plasma calcium from minute to minute basis. While the slow adjustment, it will control the total body calcium, and this by ensuring the equivalence between how much calcium we took and how much we are excreted, and this will take longer time, weeks or months. The immediate adjustment, it's through rapid exchange between the bone, the huge reservoir of calcium, and the extracellular fluid, as we will discuss in details now. and also through the modification of the urinary calcium, how much urine is excreted in the urine. While the slow adjustment, it needs an adjustment between how much calcium we are taking through adjustment of the intestinal calcium absorption, and also through how much calcium we are losing through urinary calcium excretion. This diagram, you can refer to your textbook to have more details about the explanation, but usually we took in our diet around 1,000 milligram per day, like what is present in 1 cup of milk. And under the influence of vitamin D, we might absorb a maximally of 350 milligram per day. The rest will be excreted in the feces. Not only this, the GIT itself, we can lose some of the calcium through the gastric, through the GIT secretions, through sloughing of epithelial cells. So almost 90% of the calcium intake will be lost in the feces. And then this is the extracellular fluid, and this is the what is inside the cells, and this in continuous exchange in an attempt to maintain a precise extracellular or the free calcium level here. Most of the calcium in the plasma will be filtered except the one which is bound to proteins, but also almost 99% it will be reabsorbed back. And this reabsorption again under the control of the hormones like parathyroid hormone, which depend on the level of the calcium in the extracellular fluid volume. Okay, also as we said, there is a continuous exchange of calcium between the extracellular fluid and the bone, the huge reservoir of bone, to maintain a precise control of calcium level. So either through deposition of calcium in the bone or through absorption and release of calcium from the bone to the extracellular fluid volume. So there is a continuous calcium exchange between different tissues in the body. When we speak about calcium regulation, it's important also to correlate it with the bone formation. You can remember it through the rule of 3. So we have 3 important cell types that maintain calcium homeostasis: the osteoblasts, osteocytes, and osteoclasts, and these all 3 found in the bone. We have also 3 hormones, as I mentioned before: the parathyroid hormone, the vitamin D3, and the calcitonin. And 3 important tissue that play a role in maintaining calcium homeostasis is the bone, the kidneys, and the intestine. When we speak about the bone, as we said, there are 3 important cell types: the osteoblasts, osteocytes, and osteoclasts. What is the osteoblast and osteocytes? The osteoblast is the cells that form the bone by secreting the collagen and the proteoglycans, which form the soft tissue of the bone, which we call osteoid. So this is the soft part of the bone. Some of these osteoblasts migrate inside the bone and stay as a quiescent or inactive, and we call them osteocytes. So osteocyte is the quiescent form of the osteoblast, which is found inside the bone. And osteoblasts, mainly you found them near the periosteum. So after formation of the osteoid, now the calcium will be deposited on these collagen fibers. In most of the body, the calcium is not deposited in any soft tissue or in the plasma. Why? Because of an enzyme called pyrophosphate. So this inhibits calcium deposition in other tissues of the body. But in the bone, this pyrophosphate will be inhibited by alkaline phosphatase. So now the calcium can be deposited inside the collagen fibers. Some of this calcium remain in a fluid form, what we call it amorphous calcium, a soft calcium which can be easily exchanged with the extracellular fluid, and what we call it later, as you will see, we'll call it bony fluid. So the calcium here is not hard, it can be released to the extracellular fluid in a very short time. But the other calcium, within days and maybe 2 weeks, it will be mineralized and crystallized into a crystals called hydroxyapatite, and these are the hard form of the bone. And to release calcium from this hard part of the bone, you need the other type of cells, which is the osteoclast. These osteoclasts will dissolve the bone and then it can release the calcium, but this will take longer time compared to the calcium which will be released from this soft part, which be short. It will need shorter time to be released. So what is osteoclast? Osteoclasts are the cell which secrete proteolytic enzymes like lactic and citric acid that will dissolve that hard part of the bone, dissolve the organic matrix, and then it will release the calcium to the blood. They are stimulated by parathyroid hormone. So these osteoclasts, by the action of parathyroid hormone, they will be more active and it will release more calcium to increase the blood calcium level. Also, it is inhibited by estrogen through the inhibition of release of cytokines that stimulate the osteoclasts. Before I talk about the parathyroid hormone, let's see from where it is secreted. It is secreted from the parathyroid glands, which is 4 glands located at the posterior surface of the thyroid gland, and it is secreted from cells here called Schiff cells. So it is a polypeptide hormone. The chemical nature of it is a polypeptide. As I said, it is secreted from the Schiff cells, and their mechanism of action through membrane receptor G proteins that will activate the protein kinase C and the cyclic AMP. What is the actions of parathyroid hormone? As we said before, it's very important in regulating calcium blood level by acting through the 3 tissues we said: the bone, the kidney, and the intestine. So parathyroid hormone basically remove the calcium from the bone from 2 areas in the bone. If we enlarge the bone here, there are 2 pools of calcium in the bone: the stable pool and the labile pool. The stable pool, the one which we said the hard part of the bone, and this is composed of that hydroxyapatite crystals of the calcium, and this pool needs the osteoclasts to break down and then to release the calcium from these crystals. While the labile bone, we said about the amorphous calcium that is found in the bone, which is the soft bit, and it can be released easily from the bone to the plasma. Parathyroid hormone has 2 effects on the bone in causing absorption of calcium and phosphate. When we say absorption here is the same meaning as resorption. It means release of calcium from the bone into the blood. We have a rapid phase, which happened first, and then a second slower phase. The first rapid phase, what we call it osteolysis, and here it begins within a minute and increase progressively for several hours. And the slower phase requires several days or even weeks to become fully developed. So let's talk about the fast phase, which is the fast exchange from bone fluid, which is the soft part of the bone. If we see here, this is a more histological structure of the bone. This is the hard bone where the hydroxyapatite crystals found. It is hard mineralized part of the bone. And here near the osteoblast and near the osteocyte, these are the osteocytes and these are the osteoblasts. Near them is the soft part, what we call bone fluid, where the calcium here found in the amorphous form, which is easily released into the plasma. And these are the membranes of the osteoblast and osteocytes, and they can pump the calcium into the blood here in the central canal. So here, this is the rapid phase. So the rapid phase, the calcium will be removed from the bony fluid, okay, which is located around the osteoblast and the osteocytes, which then will release the calcium from here, from the bony fluid, into the plasma in the central canal. And this is happen by activating some pumps here in this membrane between the blood and the osteoblast that pump the calcium into the blood. The second slower phase is the one that release the calcium from the hard bit of the bone, and as I said, this requires the activation of osteoclast to break down this bone and then to release the calcium. So here, this one needs a proliferation of the osteoclast, which then will increase their activity and increase their osteoclastic absorption of the bone. Osteoclasts themselves, they don't have receptors for parathyroid hormone. So what will happen? The osteoblast and the osteocyte got the receptors for parathyroid hormone, and then these cells will send signals to the osteoclasts, which will cause them to do the bone resorption over a longer period of time, weeks or months. And here what will happen, there will be activation of the already found osteoclasts. So there will be immediate activation of these already or preformed osteoclasts, and also there will be a formation of new osteoclasts, which will, as we said, will break down the hard bit of the bone, and then it will release the calcium. This diagram is a summary of the fast rapid phase and the slow phase of calcium exchange between the bone and the blood. So the fast phase, the calcium will be moved from the bone fluid into the plasma by activating calcium pumps here that will pump the calcium into the plasma from this bone fluid, the soft part or the amorphous calcium found in the bone. The slow one will release the bone from the mineralized bone, from the stable pool of calcium into the blood, and this required the activation of osteoclasts that will dissolve and break the bone here to release the calcium. What is the effect of parathyroid hormone on the kidneys? First, it will cause loss of phosphate through decreasing the reabsorption of phosphate from the kidney, from the proximal tubules of the kidney. At the same time, it increased the renal tubular reabsorption of calcium, and this is mainly at the distal tubules and early collecting duct, very less effect on loop of Henle. At the same time, also it increased the absorption of other ions like magnesium and hydrogen, and decreased the reabsorption of sodium, potassium, and amino acids. So the net effect of parathyroid hormone on the kidney is to increase calcium reabsorption and phosphate loss in the urine. So decrease the phosphate and increase the calcium in the blood. So in cases of deficiency of parathyroid hormone, what will happen, you think, in the kidney? So there will be no reabsorption of the calcium, and this eventually will deplete the extracellular fluid from the calcium, and because there is a compensation from the bone, and if this continue for longer time, even the bone calcium will be markedly. What about the effect of parathyroid hormone in the intestine? If you parathyroid hormone mainly increase blood calcium level, so what will happen in the intestine? It also increase both calcium and phosphate absorption, and this is through activation of the formation of the active form of vitamin D in the kidneys. How is the parathyroid hormone secretion controlled? It is basically through the negative feedback mechanism that control the ionized blood calcium level. So it depends on the blood calcium level. If blood calcium level is high, what will happen? There will be a negative feedback inhibition of parathyroid hormone. What happens if blood calcium level is low? There will be a stimulation of parathyroid hormone release. So these are the parathyroid glands secreting parathyroid hormone, which will act in the bone, the kidney, and the GIT system. So cases when we have an increase in the calcium ions, this will inhibit the parathyroid hormone release. But cases when there is calcium level is decreased in the blood, it will stimulate parathyroid hormone release, which will go and regulate the calcium and the phosphate through the action on these three tissues. Okay, so if you keep in your mind what we talked about, the parathyroid hormone secretion control, I want you to list for me 3 conditions that will cause enlarged parathyroid. When I say enlarged parathyroid gland, it means there is a lot of stimulation to the parathyroid glands to secrete parathyroid hormone. Have a minute and think what conditions might increase the need for parathyroid hormone. So if there is a hypocalcemia, there will be a stimulation, for the parathyroid gland. What condition might cause hypocalcemia? Rickets, which is calcium deficiency in kids. So this will always stimulate the parathyroid hormone to secrete parathyroid, and that's why the parathyroid glands will be enlarged. Pregnancy. Now the need for calcium is increased in the body because another body is there needs also calcium. So if there is the lady should increase her intake of calcium, otherwise there will be an enlarged parathyroid gland because there is a lot of stimulation to the parathyroid gland to secrete parathyroid hormone. Lactation also, because again the breastfeeding mother, they need to increase their intake of calcium, otherwise there will be too much stimulation of parathyroid glands to secrete parathyroid hormone. Okay, now also I want you to list for me 3 conditions that will reduce the size. When we say reduce the size, there is no stimulation of the parathyroid gland, so with the time the size will be reduced. So what conditions that inhibit release of parathyroid hormone? Any condition with high calcium, hypercalcemia, like if there is excess intake of calcium in the diet, which will increase the plasma calcium level. If there is an increase in vitamin D in the diet, which will increase the absorption of calcium from the GIT. And in some conditions where there is resorption of the bones, like disuse of the bones, this will increase the rate of calcium release from the bone, which will increase the plasma calcium level, which will inhibit the parathyroid glands. Okay, clear? The other important hormone in calcium homeostasis is calcitonin, but this hormone is more important in growing kids rather than adults. Calcitonin is a peptide hormone which is secreted by thyroid gland. If you recall, there is another cell type in the thyroid, C cells, which secrete this hormone. Its function is opposite to parathyroid hormone. So the parathyroid hormone increase the blood calcium level. The calcitonin do the opposite. It decrease the plasma calcium level. As I said, it is secreted by the parafollicular cells or C cells, which is in the interstitial tissue between the follicles of the thyroid gland. Not interstitial fluid, sorry, interstitial tissue. The primary stimulus of calcitonin now, if their action is to decrease plasma calcium, so the stimulation will come from any condition that increase the plasma calcium ion concentration. So calcitonin will decrease the calcium level by rapid action. If any experiment done and a calcitonin injected to any animal, the calcium level will be reduced within a minute. What are the functions of calcitonin? The immediate effect is to decrease the release of calcium from the bone through inhibition of both things, decrease the absorptive activities of the osteoclasts and also decrease the osteolytic effect, the immediate effect we spoke about before at the osteocytic membrane throughout the whole bone. It also here, the calcitonin, and this is why it is important in kids, it will shift the balance in favor of depositing calcium in the bone than removing it from the bone. And this is very important, as I said, in growing children because they need to grow their bones. Also, the second more prolonged effect of calcitonin is through decrease in the formation of new osteoclasts. So the osteoclast will be reduced. At the same time, because there is always a balance between the bone resorption, the osteoclast activity, and the bone deposition, the osteoblast activity. So if there is a reduction in the formation of new osteoclast, this will be in the long run also there will be a reduced in the osteoblast number of cells. It has a very minor effect on the intestine and the kidney. How is the calcitonin level controlled? The same thing, the blood calcium level will control this, the free calcium actually, the free bit. So if there is a high calcium level, there will be an increase in the release of calcitonin, and if there is low calcium level, there will be a reduced release of calcitonin. Also, there is other hormones, especially from the gastrointestinal system, like gastrin, cholecystokinin, BZ, glucagon. All these really increase the release of calcitonin level. Here, I want you to note that the most important in controlling blood calcium level is the parathyroid hormone, more than the calcitonin, especially in adults. So it's a very short regulatory mechanism, but the most important one is the parathyroid hormone mechanism in controlling the calcium level. What about vitamin D? It's another important hormone that is controlling the blood calcium level. The source of vitamin D is from the skin as 7-dehydrocholesterol, and also it is from the diet as cholecalciferol, which is a fat-soluble vitamin. Then the active form is formed in the kidney as 1,25-dihydroxycalciferol. It is chemically a sterol hormone. If you see here in this diagram, the ultraviolet rays of the sun will change the 7-dehydrocholesterol in the skin to cholecalciferol, which is the vitamin D3. And then in the liver, it will be changed to 25-hydroxycholecalciferol, and the level of this will have a negative feedback inhibition on the rate of forming this 25-hydroxycholecalciferol. Then this 25-hydroxycholecalciferol in the kidney, under the effect of parathyroid hormone, it will be converted to the active form of vitamin D, which is 1,25-dihydrocholecalciferol, which then it will go and increase the mainly affect the intestinal epithelium to increase calcium absorption. So the level of calcium here, it will control as negative feedback inhibition the parathyroid hormone, which will affect the activation of the vitamin D in the kidney. What are the actions of vitamin D, which is the active form 1,25-dihydrocholecalciferol? Main action is on the intestine by increasing the calcium absorption, and this is mainly by increasing the formation of calcium binding proteins. This protein will bind to the calcium, then it will transport the calcium inside the cell, and then through facilitated diffusion to the extracellular fluid. Also, the vitamin D is forming calcium stimulated ATPase in the brush border, and also formation of alkaline phosphatase, where the particular action is not that much clear. Also, it increases the intestinal phosphate absorption, but it's not important as increasing the calcium. What is the action of vitamin D on the bone? It increases the mobilization of calcium and phosphate from the bone, which is very mild effect. Another important action for it is a synergistic action with parathyroid hormone, which means vitamin D increase the responsiveness of the bone to parathyroid hormone, which will increase the proliferation of osteoclast, as we said before. On the kidney, it increases the calcium reabsorption in the distal tubules, and also increase tubular reabsorption of phosphate in the proximal tubule. But again, these are weak effects. So the main effect of vitamin D is on the intestine. The others are really weak effects. So in summary, active form vitamin D is increasing plasma calcium and also phosphate via mainly absorption through the GIT tract, and also to a lesser extent is increase the bone resorption and renal reabsorption of the calcium. So there is an inverse relationship between the calcium level and the level of vitamin D. So in cases of high calcium, there will be a reduction in vitamin D3, and cases of low calcium, there is an increase in vitamin D3. What is the effect of parathyroid hormone on vitamin D? We already spoke about it. It converts the 25-hydroxycholecalciferol to the active form of vitamin D, which is 1,25-dihydrocholecalciferol. So parathyroid hormone is very important in the metabolism of vitamin D, which then the active form, as we said, it will increase calcium reabsorption from the intestine, and also it goes synergistic effect to parathyroid hormone effect. This last diagram, I want you to work through it alone. Just tell me what will happen when there is a high level of calcium in the blood. Which hormone will be increased, which hormone will be decreased, and how the calcium will be increased or decreased. And the other things, what will happen when you have a low level of calcium. We already mentioned it in our discussion, and this is very good exercise for you to trace the events that happen when there is a high calcium level or there is a low calcium level. Thank you for listening, and if you have any questions, please email me, and please go through your textbook for any queries before emailing me, because all the information is there. I'm only summarizing them here. Thank you very much.